Yo, 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 yo. All right, everybody, we're going to solve quadratic equations using factoring this time. So we're not going to graph, we're not going to use tables. We're going to factor. So this is a new way to learn, or new method for solving quadratic equations. So first, key terms, standard form, we've already seen it before, but it's good to see it again. But the standard form for a quadratic equation is when it is equal to 0. And then the zero product property. So for all real numbers A and B, so no matter what number A and B is, if we multiply them and it equals 0, then either A or B has to be equal to 0. So like if I know that 2 times x equals 0, I know that x has to be equal to 0 to make this work, right? So no matter what, if you multiply two numbers and it equals 0, one of those two numbers has to be 0. And we're going to use that property in order to solve these equations. So first, let's look at solving an equation that looks like this. Right now, we don't have the squared. Okay, but if I wanted you guys to solve this equation, what we know is I have some value a. We're going to call this a because this is just, we can look at this as one term because both of these values are inside parentheses. So that's like one term a, and that's like one term b. So if I multiply whatever this value, x minus 9 is, by whatever this is, 5x plus 2, it's going to equal to 0. So one of these two values has to be equal to 0 for this to be true. So if x minus 9 was 0, then this would make this whole thing 0. If 5x plus 2 ended up being equal to 0, then this whole thing would be 0. Because when you multiply by 0, you get 0. So the way I would solve this equation is I would actually solve it by solving two different equations. If x minus 9, if just this term right here is equal to 0, then this whole value, everything is equal to 0. So I can set it up as x minus 9 equals 0, plus 9 on both sides, x equals 9. So if I were to plug in x equals 9 into this equation, well, that would give me 9 minus 9, which is 0. 0 times 5 times 9 plus 2, whatever 5 times 9 is plus 2, it doesn't actually matter because 0 times anything is 0. So it gives me a solution that works. So what I also need to do though is that's one possible solution for this equation. There's going to be another solution, and that's if this term is equal to 0. So I can set up a second equation as 5x plus 2 equals 0. Because if this whole value is equal to 0, then this whole equation is equal to 0. Well, I can subtract 2 from both sides. I get 5x equals negative 2 divided by 5. X equals negative 2/5. Or you could put x equals negative 0.4. Either one of these answers would be acceptable. So now if I have x be this value, if I plug that into here, it's going to give me 0. It doesn't matter what it gets me over here. Negative 0.4 minus 9 is negative 9.4. Okay, so that's what's going to give me here. But here, if I go negative 0.4 times 5, it's going to give me negative 2. And then negative 2 plus 2 is 0. So it also gives me a solution. So the solution to this equation is x equals 9, x equals negative 0.4, or x equals, I missed on my target there. Or you could have also just put it as a fraction. Go ahead and solve this equation on your own. Find out if we have one or two solutions, to figure out what those solutions are for this equation down here. It's positive if you haven't done so already. So again, because I have two groups of numbers here, two terms, if one equals to 0, then both equations are, then the whole equation is equal to 0. So I'm going to have two solutions. 2x minus 1 equals 0, and whatever x plus 3 is equal to 0. Oh, add 1 to both sides, I get 2x equals 1, so x equals 1/2. Subtract 3 from both sides, x equals negative 3. So if x equals 1/2, it's going to give me 0 on this side, which is to make all of this equal to 0. If x equals negative 3, it's going to give me 0 on this term, which makes everything equal to 0. So those are my two solutions for this particular equation. Now, these are quadratics, because if I were to multiply these, 2x times x, that's 2x squared. If I were to actually simplify these to get rid of the parentheses, this would give me 6x, negative x, negative 3. So this actually simplifies to 2x squared plus 5x minus 3. So this is a quadratic equation. So before, we would have had to graph this and then find out what the intercepts, the x-intercepts are, what the zeros are of the function. So now this is one way to solve it if we were to write it in this form. And that's where factoring comes into play. So when we factor, we can factor a quadratic function to go from here to here, and then we can solve the equation that way. So, because I could factor this by doing slide and divide, right? So I can make it x squared plus 5x minus 6, and then I can factor out this, so this is going to give me x, let's see here, I'm looking for factors of -6 that are going to give me to +5. Well, factors of -6 that give me to +5 are x, let's see here, it's going to be 6 and 1, so x plus 6, x minus 1, and let me rewrite this up here. Now I have to divide all those things by what I multiplied by in the beginning. X plus 6 is x plus 3. And then this I can't, so I move it over. So I get 2x minus 1. And look, so I went from here to this. And then now I can solve the equation. So this is a quadratic function that we have factored, that's already been factored out. So these two things are equivalent to each other. So that's how we solve these equations without having a graph, is we can solve them by using factoring. So what I can do is, one, I have to write this in standard form, so I have to move the -20 over by adding 20 to both sides. So I get x squared plus 9x plus 20 equals 0. So now it's in standard form. Well, now that I'm in standard form, I can factor this. So I'm looking for my factors of 20 that add up to 9. Well, that's x plus 5. And x plus 4. I didn't have to do slide and divide because there's no a term here. Now that I've factored it, I can figure out, okay, well, what values for x are going to give me 0 for each term? Well, if I subtract 5 from here, I subtract 5, because that's going to be, well, I went ahead. I'm already skipping ahead as if we already know what we're doing. So I can set up my two equations. It's x plus 5 equals 0, x plus 4 equals 0. Because once I solve both of these equations, it's going to give you my two possibilities for x. I can solve these both, and I get x equals -4. So these are my two solutions to this quadratic equation. If I were to plug these into this equation, it would get me, 0. Or if I were to plug these into here, it would give me -20. So these are my two possible solutions for these equations, or for this equation. If I were to graph it, these are the x-intercepts. So go ahead and try, let's try this one first on your own. Let's see how you do. So pause it, try it, see what happens, factor it, see if you can solve the equation. So I'm looking for factors of 64 that add up to 16. So that's 8 and 8. So that's just x plus 8 and x plus 8. 8 times 8 is 64. And then 8 plus 8 is 16. Well, these are the same thing. So when I solve this, I subtract 8 from both sides. This is one of those examples where I have just one solution to the equation. This is x minus 8. So that means this is the only x-intercept, which means the vertex is on the x-axis. And go ahead and try this next one and see how you do. So pause it, try it. So first step is to subtract 64 from both sides and write it in standard form. Now I'm looking for factors of -64 that add up to -12. Well, 16 times 4 is 64, and 16 and 4 make 12. So I just got to make sure I got my positives and negatives right. So I know one's got to be positive, one's got to be negative. Because my middle term's negative, that means the larger term has to be negative. So -16 times +4 is -64. -16 +4 make -12. Well, there's my two equations. So I can add 16 to both sides. I get x equals 16. This one, I get to subtract 4 from both sides. I get x equals -4. And those are my two solutions for this particular equation. And again, if you want to check it, you can. I can plug in -4 here. -4 squared is 16 minus, let's see here, 12 times -4. which is 16 plus 48, which is 64. Okay, so you'll have some word problems. So with these word problems, you're going to have to set it up where you're probably going to have to set it up where you're going to have to find the area or factor or something along those lines. So let's look at this one. A museum vault has an outer steel wall with a uniform width of X. Okay, so here's that uniform width right here. So this right here is X. The area of the museum vault ceiling is 1,664 feet. What is the width of the outer steel wall? So here I know this right here, I'm given this width is 20, and this one is 40. Okay, so but I also have to add X. So that's going to be 2X plus 40 for this entire length. This entire length is also going to include the width of this X and X plus the 20. So that's going to give me 2X plus 20. And if I multiply those, it says the area of the museum vault ceiling and the outer steel wall is 1,664. So if I multiply those two things together, I get 1,664. So there is my quadratic equation. So now I can go ahead and, well, there's a few routes of how I can do this. Okay. What I want to do is I'm actually going to multiply this out. So I'm going to distribute. And the reason why we're going to do this is because if we notice we have large numbers for one, but two, is all of these we can factor out something already out of all of this. And so I want to multiply it out to show you what we can factor out so that we don't actually have an A term. So let's see here, I got 2x times 2x, that's going to give me 4x squared. And then I'm going to get, let's see here, plus 40x plus 80x plus, let's see here, 40, that's 800, sorry. That's going to give me 4x squared plus 120x plus 800 equals 1,664. Another reason why I'm doing this is here, I'm sorry, this is really the main reason why I'm doing this, because this isn't in standard form, because this isn't equal to 0, and I've got to set it equal to 0. So then from here, I can subtract 1,664 from both sides to set it equal to 0. That's the main reason why. I gave a poor explanation earlier. Now when I subtract these, I will get negative 864, and all of that is equal to 0. Now one thing, and this is another part when I said these are all really large numbers and I know we can get rid of an A term, is because now if I look, I can divide all this by 4. So if you have these really large numbers like this, factor it out. I can factor out a 4 here. I can divide everything in this equation by 4, and I'm doing it on both sides. So I'm dividing both sides by 4 is what I'm doing. But what that does is this makes this a pretty friendly equation to work with. Okay, because this is going to give me 30x, and then let me just plug this in real quick. It's going to give me negative 216, and it's still equal to 0. So by dividing all this by 4, I have a lot more friendly numbers to work with. So now I'm looking for factors of negative 16 that add up to 30. And yeah, this might take a little bit of thought that goes into this, right? But that's okay. And it's going to be 36 and 6. So, and I know it's going to be negative and positive. So negative 36, I'm sorry, positive 36 and negative 6 equals 0, because positive times a negative is negative, positive 36, negative 6 makes 30, and now these are my equations that I can solve for my possible widths. So I would have gotten x equals negative 36, and I would get x equals 6 for the widths. Now, this is to find the width of this container, right, or of this steel, the outer steel wall. However, is it possible for a width to be negative? No. So therefore, negative 36 is not a possible solution, so it's just x equals 6 for the width of the outer steel wall. Okay, so the first thing we did is we just wrote out our area by finding the whole area of the whole entire piece, because we knew the area was 1,664, but I had to multiply it out to simplify it so I can make it equal to 0, because I had to be able to subtract this 1,664, and then I went and factored out that 4 so that I could start solving my equation by factoring. Okay, a couple more problem types that we're gonna have. So we're gonna use factoring to graph the function. So to factor to graph the function, all we're gonna do is we're looking for 3 points. I'm looking for the x-intercepts, and I'm also looking for the vertex. So we still have to use our negative b over 2a to find the vertex. So like for this particular one, it's gonna be negative 2 over 2 times 1. So that's negative 2 with the double negative, that's gonna give me positive 2 for my x value. So if x equals 2, so I have 2 squared minus 2 times 2 minus 8, 4 minus 8. So it looks like I'm getting a vertex of positive 2 and negative 8. Okay, so now what we're going to do, oh man, I made a huge mistake. This happens when I rush, you guys. Negative 2 over 2 is not negative 2, it's 1. My goodness. So it should have been positive 1. I'm sorry. At least you guys saw me make a mistake. You realize that this is what happens when I go fast. Alright, so that's 1 squared minus 2 times 1 minus 8. So it's going to be 1 minus 2 minus 8, which is going to give me negative 9. I apologize for that. So that's positive 1 and negative 9, which is, you know, this is 7. Let's go 8, 9, so that's right here. Now what I can do, I have my vertex. Now I just factor, and that's going to give me my x-intercepts instead of graphing, instead of doing anything else. So now I can factor this out to figure out the x-intercepts are. And then when I do that, when I do that, it's going to give me my other 2 points. So factors are negative 8 that add up to negative 2. Let's see here, that's going to give me 2 and 4. So x plus 2, x minus 4. So that means my x is negative 2, x equals positive 4. So those are my 2 x-intercepts. Whoops, I missed, but we're okay. There's my graph. Okay, so if you still find the vertex, that part doesn't change, but now you're factoring to find 2 other points to find those zeros or those x-intercepts. You can also write the factored form of a quadratic function related to a graph. Okay, so for this, what we're going to do is there's a couple steps to this. Okay, so what we want to do for this one is first we have to make sure that we have the a value included. That's the one part that gets a little bit tricky with this, writing the vertex. So what I know is I know that we have negative 5 for a solution and 1 for a solution. So because of that, because it's positive 1, I know that means it has to be x minus 1. And I know that has to be x plus 5. Okay, because if I subtract 5 from both sides, it'll give me an x-intercept of negative 5. If I add 1 to both sides, it'll give me a solution of positive 1. But we want to make sure that there's no a term that's being multiplied by one of these that's going to be in front of the x. So this is my function. I set up my 2 intercepts to get me to 0, but I have to make sure that there's no a value right here in the front. Okay, so from here what I'm going to do is I'm actually going to plug in a point to solve. So I'm going to plug in a point to solve this particular equation. So instead of having this be equal to 0, this be equal to 0 would give me these 2 functions. But to have this equal to 0, I'm going to plug in a point which is my vertex. So I'm going to plug in negative 2 for my x values. And I'm going to plug in negative 9 for the y value, because this 0 is really just your y. And then now I can solve the equation for a to make sure that there is no a value here. So I plugged in my vertex, I just plugged in my point, negative 2, here's my x, here's my y. So this gives me negative 3 times 3 times a equals negative 9. Well, this gives me negative 9a equals negative 9 when I divide it by negative 9. I get a equals 1, so that one worked out. So if I had something that wasn't 1 here, I would just then distribute that. Okay, but because I got 1, I can plug in a 1 in front, and it doesn't do anything, so there's my final solution. So that would be my quadratic equation. Okay, in factored form. If it asks me for standard form, I can then multiply this out and put it into standard form. Okay, that's all I got for you guys. I hope this helped. I hope this looks a little bit easier than graphing. We'll get some practice in. If you have any questions, let me know. Pretty us out.